This video is sponsored by Masterworks, the art investing platform. More about them at the end of the episode. This is an incredibly complex device with truly astronomical capabilities. Next to this, the Death Star is like a child's toy. Collecting and using all the solar energy with the help of a giant Dyson sphere has long been a dream of sci-fi writers, and we're used to thinking of this as like a perpetual motion machine, a strange fictional device that will never be built, let alone work. But what if some advanced civilizations don't think so? Perhaps, right now, alien engineers are building their Dyson spheres, accumulating the incredible star energy, and in the end, using it for their space mega projects. What's more, we can see traces of all this in the sky even now, especially with the new James Webb Telescope. So, where could astronomers notice these clear traces of working Dyson spheres among the cosmic anomalies? Even preparations for constructing a Dyson sphere are quite challenging to hide from prying eyes. After all, only the first-type civilization, according to the Kardashev scale, can work on this project, that is, beings who've already mastered all the resources of their planet and now want to rise up one step higher to get the energy of their native star and become a second-type advanced civilization. But the price of this upgrade is hefty. To build the smallest Dyson sphere in our solar system, that is, inside Mercury's orbit and only 1 meter thick, we'll need to get a lot of heavy-duty building materials, and they weigh like 40 Earths. For a structure as wide as Earth's orbit, we'll need 7 times more, that's almost the mass of Jupiter. All this raw material will be picked up by an armada of self-replicating probes that will gradually build the sphere piece by piece. So, can it be that someone has already solved this engineering problem? Not far from Earth, the star Fomalhaut is only 25 light-years away from us. This blue giant is 15 times brighter than the Sun, and its light showed something very unusual. With the help of Hubble, scientists were able to make a unique optical image of a massive planet in the far orbit of Fomalhaut. The first calculations showed that the celestial body, Fomalhaut b, is almost twice as heavy as Jupiter. Or so it was thought. Astronomers couldn't believe their eyes when, in just a few years of observation, the giant planet had evaporated. Of course, there's no way that could happen, so we had to urgently change the theory. Supposedly, it wasn't a planet that revolved around Fomalhaut but just a massive cloud of dust which, for some unknown reasons, suddenly dissolved. But it never occurred to anyone to calculate that about 2 masses of Jupiter is just the right amount of raw material for a Dyson sphere around a giant star like Fomalhaut. Perhaps we were lucky enough to catch the moment when a swarm of robots from an advanced civilization dismantled the planet for building materials and was about to start assembling a stellar generator. Right now, we can see something very similar to this process in another corner of space. Tabby's star, almost 1,500 light-years from Earth, behaves so mysteriously that astronomers have given it another nickname, WTF star. At first glance, this is the most common yellow dwarf, about 1.5 times more massive than our Sun. Such stars usually radiate energy in a very stable and predictable manner. But there's one problem: from the beginning of the 2010s, the brightness of Tabby's star started to decrease suddenly and strongly, up to a quarter of the norm. At first, astronomers thought an exoplanet obscured the star from us every now and then. However, according to all calculations, such a celestial body should be 10 times larger than Jupiter, that is, in fact, another invisible star. Then Tabby's star went berserk and started acting just like a broken light bulb in your basement. These irregular and huge light fluctuations are simply impossible from the perspective of physics, which means the reason is definitely not the star itself. So, what is it then? To explain Tabby's anomalies, scientists have imagined an asymmetric dust cloud, dozens of comet swarms, and even an exoplanet colliding with a giant killer asteroid that split it apart. But each of these hypotheses also fell apart during the next dimming of Tabby's star. Only a few scientists cautiously suggested that only a gradual overlap of the star with freely drifting segments of a Dyson sphere would give such a picture. It looks like it's being assembled right now. Even if Tabby's luminosity subsides even stronger and more chaotically in the coming years, this will become a decisive argument in favor of the fact that we are observing nothing more than a construction site of an advanced civilization. But what does an already completed stellar generator look like? Distinguishing traces of alien Dyson spheres work is challenging, but we already have some leads. In his legendary article in 1960, the author of the original idea himself, mathematician Freeman Dyson, didn't talk about the construction of these megastructures at all, at least, how we can see them. Dyson pointed out that such an object, when collecting and transforming stellar energy, would inevitably begin to release heat. Its temperature would be about 300 kelvins, that is, like beer left in the heat. For space, this is very hot. At the same time, the Dyson sphere will be larger and more massive than any natural cosmic body with such thermal radiation. After all, an entire star is inside of it. What Dyson didn't think of was how the stellar generator would deliver its power. After all, it's simply impossible to stretch a cable through space from a sphere to a planet. NASA's space-based solar power project since the late 70s gives us one crucial hint. It's basically a very minimalistic version of a Dyson sphere. Scientists have concluded they'll need a repeater to deliver space energy to Earth. Solar collectors will fire high-energy lasers at it every now and then, and from there, beams of microwaves will be sent to Earth's surface. This means a real working Dyson sphere should radiate in several ranges simultaneously. We've already spotted something similar. Brown dwarfs are mysterious objects that weigh too much to be normal planets but are too small to be stars. They have a mass of between 10 to 80 Jupiters, which supports barely smoldering nuclear reactions. As a result, typical brown dwarfs emit infrared radiation with temperatures up to 1000 kelvins. This is at least 3 times hotter than a working Dyson sphere. But there is a unique exception. Astronomers stumbled upon this mysterious object in old Spitzer infrared data from the early 2010s. According to them, this barely discernible dot can only be an anomalously cold brown dwarf with infrared radiation at a level of only 260 kelvins. What's even more intriguing is that the mass of the object could not be accurately estimated because it drifts 7.5 light-years from Earth all alone. Because of this, the true strength of its gravity is tough to calculate. Astronomers only assume that the object has between 3 and 10 Jupiter's masses, but that's only because they consider it only as a brown dwarf. It may also be a star, a red dwarf inside a small Dyson sphere, and it releases only the residual working heat outside just in the range that Freeman Dyson predicted. From Earth, such a Dyson sphere would look just the same, a faded, blurry point of unknown mass. Dyson swarms. Until now, NASA has found only 24 really cool brown dwarfs, and there may well be several more stellar generators hiding among them. Although, according to Freeman Dyson himself, even an advanced civilization would hardly spend money on a full sphere around a star. They would rather use a more budget-friendly option of a swarm of collector probes in orbit. Oddly enough, they should be more visible. A Dyson swarm similarly radiates heat when working, but it doesn't hide all the star's light from us. Instead, it adds an anomalous peak to its infrared spectrum. In 2022, a team of American astronomers used data from the Gaia Space Observatory to analyze 260,000 stars in our galaxy for such infrared anomalies. The result exceeded all expectations. The problem with Dyson swarms ***. Among the studied stars, from 20 to 200 Dyson swarms of various configurations could be operating right now. Although there are natural explanations for most of the anomalies, such as gas and dust clouds, isn't this precisely the reason to examine suspicious stars using James Webb's excellent infrared sensors? Alas, NASA doesn't think so because Dyson spheres and swarms are still considered too fantastic to exist in reality. If the James Webb is never tasked with searching for alien stellar generators, the rest of the accompanying evidence could theoretically confirm the sensational findings. For example, those laser and microwave energy transfers from stellar collectors to the home planet of another civilization. But here's the problem: these rays scatter so quickly that they're indistinguishable from background noise, even for the most advanced terrestrial telescopes. It seems that at this point, we can only shrug and get desperate, but I suggest we go further than even the most open-minded scientists. Dyson spheres swarms ***. If we unravel the real purpose of Dyson spheres and swarms, we'll find that they've already unambiguously shown themselves. Judge for yourselves: if we acquired such a stellar generator, we would have at our disposal at least 400 septillion watts of energy for millions or billions of years to come. This is almost 60 trillion times more than our power plants produce today. That amount of energy is even too much for mundane tasks like heating homes and charging gadgets. But what's the point of using it then? Having built its sphere or Dyson swarm, civilization will soon reach the second level on the Kardashev scale and begin to gradually move towards the third, that is, to colonize the whole galaxy to use all of its resources. This means that such a civilization will sooner or later have to solve the problem of interstellar travel, and it's just the Dyson sphere or swarm that will help with this. A few years ago, the Hubble Space Telescope spotted an unprecedented anomaly. Some invisible object passed in front of a distant star and distorted its light with the effect of gravitational lensing, more precisely, microlensing. After all, the object turned out to be surprisingly tiny. According to astronomers, Hubble had seen a lone black hole wandering through space for the first time in history. But, as with an isolated brown dwarf, it's impossible to accurately determine its mass. It's from 1.5 to 7.5 suns. So for now, this black hole is officially considered unconfirmed. That means it could be something completely different. After all, a ship with a warp drive could produce the same microlensing effect. It distorts the very space-time around itself to accelerate to enormous speed, up to the speed of light. And that's not fiction at all. *** radio bursts ***. Now, physicists worldwide are trying to calculate the exact parameters for creating and maintaining a warp bubble. In the future, NASA plans to build a prototype ship based on the best theory. But today, one thing is already clear: the warp drive will need an incredible amount of energy that humanity just doesn't have. What would undoubtedly be able to provide it is a sufficiently powerful Dyson sphere or swarm. The energy of the stellar generator would first have to be accumulated and only then immediately used for warp ignition. Isn't this the shift we accidentally saw among the stars? For a noticeable microlensing effect, it doesn't need to be gigantic. According to the theory of relativity, the warp bubble's colossal energy will give the ship the illusion of an enormous mass, as if it were a black hole. But what if this process of hypercharging from the Dyson swarm suddenly gets a bug? Astronomers call these mysterious bursts of energy that last a matter of milliseconds fast radio bursts. They get to Earth from all directions from very distant galaxies, and this means the energy of radio bursts is massive, comparable to the energy output of the Sun for many months at once. But the most exciting thing is that astronomers have no idea what produces such bursts. Out of desperation, scientists embark on theories that were previously considered taboo. So in 2017, researchers at the Harvard-Smithsonian Center for Astrophysics hypothesized that fast radio bursts are nothing more than a concentrated beam of energy from a Dyson sphere or swarm that, for some reason, missed an interstellar ship and, for millions of light years, this charge did not dissipate but simply lost most of its energy, turning into radio waves. According to another version, fast radio bursts may be fragments of interstellar communications, and only a Dyson sphere swarm is realistically capable of powering such a cosmic internet. Finally, the mysterious radio flares could be emergency reset exhausts on stellar generators. It's kind of like a fuse, after all. If it accumulates too much energy in the very center of the Milky Way, astronomers have found a small star whose past hides a cataclysm of incredible power. It doesn't have a name, but its speed is legendary. This star hurtles through space at a record 24,000 kilometers per second, that's 8% of the speed of light. Such a frantic impulse could not come from nowhere. According to astronomers, this star was once part of a binary system, but eventually, its partner went supernova. This powerful explosion pushed the star to the galaxy center with great speed. But what if we actually see the echo of a terrible accident on a Dyson sphere or swarm? For some reason, its energy storage was overloaded, and its uncontrolled release blew the megastructure apart, simultaneously shooting this star out with incredible force. Too unreal? Not at all. Sometimes, astronomers detect anomalously powerful supernovae that leave nothing of the star, not even a black hole. To explain this, we have to develop extreme physical theories. But perhaps everything is quite simple, and every now and then, obliviously, we observe incidents with Dyson spheres. However, sooner or later, an advanced civilization must learn from its mistakes and move to a new level of exploitation of its generators. The Dyson Energy System 1730. Be surrounded not even by single spheres or swarms, but by the whole Dyson Energy System, a very advanced civilization that reaches the third galactic level on the Kardashev scale. We'll immediately begin to think about the fourth level, that is control over entire clusters of galaxies and ultimately the entire universe. To satisfy its needs, such a civilization won't only have to build many Dyson spheres or swarms around the brightest stars, but also find a way to quickly transfer their power over vast interstellar distances. Not just faster than the speed of light, but virtually instantaneous for the needs of such a network. Slowly getting energy out of a star over millions and billions of years would be too slow. All this means that civilizations of the third or fourth types on the Kardashev scale will have to develop fantastic technologies to overcome natural limitations. Their work will be practically magic for us, and almost magical transformations are happening in the universe right now. This young red dwarf, 460 light-years from Earth, behaves even more mysteriously than Tabby Star. Its luminosity dips 3 times as much, 2/3 and even more, and then suddenly recovers as if nothing had happened. So far, such dimming of the star is entirely inexplicable. Astronomers have calculated that a swarm of 600,000 giant comets would be needed for such an effect, which is absolutely implausible. Therefore, the best version of scientists is an asymmetric protoplanetary disk of a bizarre shape. But no one has the slightest idea why it's just like that. And if even the official hypothesis sounds fantastic, why should we ignore even more logical ones? This star may well be the victim of a super-advanced civilization that doesn't even need to build full Dyson spheres or swarms for its own purposes. A ring or other small form is enough. That's all because alien engineers have mastered the technology of quickly extracting energy from stars. Basically, they're doing stellar vampirism to fuel their Dyson network. The fact that unfortunate stars fade away in a matter of decades doesn't bother them, just like we don't care about the fate of the poor oil reservoir somewhere underground. But entire stars can't just disappear without a trace, or can they? The Blue Giant 2016. This dwarf galaxy, 75 million light-years from Earth, has a blue supergiant at its core, 2.5 million times brighter than the Sun. Or rather, it was definitely there back in 2011, but judging by the observations of 2019, there's no longer any star in this place at all. Scientists thought that they had simply missed the supernova that tore apart the blue giant. However, there are no signs of an explosion nearby, and astronomers, as usual, took up complex theories about giant stars' spontaneous and traceless collapse. We've already been through this, but after all, the one that put out the light and the brightest object in the galaxy could also be an independent super-civilization using a super-efficient Dyson device. Moreover, such mysterious disappearances occurred not only somewhere in deep faraway space. Recently, astronomers compared old photographs of the starry sky of the 1950s with new modern ones. They expected that modern telescopes would see many more stars, but it turned out quite the opposite. Some of the stars from the old catalogue seem to have vanished. In total, astronomers have identified about 800 cases of mysterious disappearances, and all of this is nearby in our galaxy. And that's only what we know. No process known to us can explain such behavior of entirely different stars. It's literally space magic, or someone really powerful installed their Dyson devices on these stars and sucked each one without a trace in a matter of decades. But the main question remains open: how does a star-eater civilization manage to instantly transport energy to other corners of space? Perhaps the answer is the so-called Pogues object. This is an extremely unusual ring galaxy with a mass of up to 700 billion stars, which is much heavier than the Milky Way. For half a century, cosmologists have been thinking about why it has such an unnatural shape. What forces push the stars around to their edges? Some scientists suggest that a giant wormhole could exist in the center of this galaxy. This is the spatial tunnel predicted by Einstein, which allows you to instantly move between the distant corners of the universe. Count regulations show that the alleged wormhole at the center of Pogues object should have had tremendous energy comparable to the energy of many tens or even hundreds of stars. And at the same time, it turned out to be extremely unstable. Its explosion of eerie power must have scattered the stars in the form of a ring. According to scientists, such an event could occur only shortly after the Big Bang, when tremendous energies were raging in the universe. However, wormholes would also be perfect for a modern super civilization for instantaneous energy transfer across the galactic network. Dyson devices would just provide the right amount of power, comparable to tens and hundreds of stars. Who knows, maybe a tragic accident on one of the systems led to the appearance of Hoag's object, destroying the entire network and creators. However, the indisputable proof for the existence of Dyson spheres may be even more apparent and closer than we imagine. This is the so-called Matryoshka brain, a hypothetical supercomputer the size of a planet. Only a Dyson sphere could supply it with energy. Even the second-type civilization on the Kardashev scale could theoretically build such a calculator, but for what purpose? To find the answer to the ultimate question of life, the universe, and all that? Not necessarily. Just look around. If such a supercomputer exists, all these amazing graphics and special effects around you are provided by a quietly humming Dyson sphere somewhere in the real world. What civilization do you think could create a simulation of humanity or even the entire universe? And most importantly, why? If we truly live in a simulation, it somehow put us in the middle of historically difficult times, times that Masterworks has helped over 600,000 people adapt through, including many of you. See, Masterworks paid out tens of millions in returns last year alone. Yes, tens of millions, including 2 exits just since we last talked about them. And now they want to do it for you too. Masterworks doesn't do NFTs or crypto. You're investing in real physical paintings, qualifying with the SEC. And as we said, some of you may have seen a return from Masterworks because just since our video in December, they sold another 3 paintings, which returned an incredible 10 and 35 net to their investors. But best of all, right now you can claim a complimentary Masterworks account just by signing up with my link below. Thank you.